Today I'm going to be sharing about our product for the Summer Tech Challenge, but before I do so, I want to explain the problem that we're trying to solve. So for most cryptocurrencies, transaction costs are a big factor when determining when you want to transfer cryptocurrency or conduct computations, for example, on the Ethereum network. So, for example, at this point in time, the cost of conducting a transaction or computation on the Ethereum network would be 19 Gwei, but in an hour later, it would cost 109 Gwei. So can you imagine if you're trying to purchase a plane ticket to Amsterdam and it costs $100 now, but it could cost $500 later? Or the converse, maybe it costs $100 now, but it could cost maybe $50 an hour later. So I think there's a lot of uncertainty as to when transactions and computations should be made. I think a user of cryptocurrencies like Ethereum, which I think is the second largest blockchain by market cap right now. One thing they'll ask themselves is, should I wait or should I make transactions and computations right now? So what our product does, what our website does, is that we make predictions on how gas prices will vary for Ethereum in the next 12 hours. So, for example, according to our website and our data analysis, we expect gas prices to remain flat for around 5 hours, then spike to a peak of 30 in around 8 hours, and then decrease after that. So we hope that our website will give users some certainty and some maybe foresight into what they should do regarding transactions and computations. So now that I've explained what our product does, I'm going to go more into how our product works. So the first step is data wrangling. So we get minute level gas information through cron jobs. And how we do so is we query publicly available sources like EtherScan and Dune through a cron job. So what EtherScan does is it analyzes the Ethereum blockchain to look at recently completed transactions, be it computations or transfers, to determine at what price these actions were done. So, it's a demand and supply system and they want to find out the clearing price. So we take this price, store it in our database every minute, and every 2 minutes we shove it into our forecasting algorithm, which then caches the results that you see here in our backend server, so that users who want to look at our website can get our predictions quickly. So, let's go more into the forecasting methods. So I think there are two important parts for forecasting methods. One is determining the period of the seasons in our data. The second is choosing a quick and yet accurate forecasting algorithm. So to determine our period, we employ two strategies. The first is we smooth out the curve, and then we use modules in SciPy to identify peaks, and then we basically find the period by taking the total amount of time between a certain number of peaks divided by the number of cycles there are. So with this period, we use a forecasting algorithm similar to Sarima, but much faster, to determine that uses fast Fourier transform to determine what predicted price should be. And once we get that information, we cache it on our server and deliver it to our users when requested, as mentioned. So yeah, I think that's a good summary of our product here. This website is available to be visited right now, and I'll include it in our application. So I would love to go more into how our cron job works, what our forecasting algorithm is like, the trade-offs between accuracy and time, as well as the hurdles that we had to navigate throughout the process. Thank you for your time, and hope you have a great week ahead.